Good morning, Professor and everyone. My name is Trinh. I come from Vietnam. Now I am student of Department of Education Chemistry. Today I will talk about the topic plastic waste with the title of paper phenolic acid-based renewable ester and amide containing epoxy from the waste brand and be useful chemoenzymatic synthesis and thermomechanical property characterization. Get started. My presentation will divide to six parts. The first introduction, the second the main ideas of the paper, third the scheme of reaction, fourth the analytical methods, the fifth results and discussion, the final conclusion. Now I will move to the first part, introduction. As we know, since the advance of the plastic industry, human life have become more convenient and modern. But the overloss of plastic waste and plastic waste thus is difficult to decompose and toxic is a challenge for the environment. Among primary materials, epoxy resin are one of the most important players of the thermoset market. However, this kind of thermoset also suffers from some drawbacks. The first, as most polymers, the restricted availability of electromechanical resources. The second main drawback of epoxy thermoset is beyond the toxicity of the famous precursor bisphenol A. This is a bisphenol A structure and thus increasing the sustainability of epoxy thermoset with the bio-based resources and substitution of bisphenol A has become the topic of increasing interest within the polymer community. The ferric acid, natural ferric acid present in the package with and right brands and Bichupro was as renewable starting material to prevent new bio-based epoxy precursors. Ferric acid by epoxy thermoset will be compared to a standard DZEBA EPDA epoxy resin by characterizing their thermal and thermomechanical property. And so is the aim of article is auto synthesize an eco-friendly bio-based epoxy resin and have a good thermomechanical property that can replace the standard thermosetting resin made from bisphenol A, which is toxic and more degradable. This is DCEBA's structure here, I list here, and so this is a scheme of the action to auto synthesize is this is a ferric acid, and after the hydrogenation to remove the double bonding here and ethanation here, this is a molecular for making the epoxy. The author uses four kinds of the starting material is the isosobite with cyclic, two cyclic with two OH group and butanedione, one for butanedione here and amide, one for butanediamide, amine and glycerol to make the ester group here and amide group here. And this group is easy to decompose in environment, and it's easy to decompose this in environment. And after epoxidation is also there's four kind of epoxide is a precursor from makes the thermoset. Plastic is this is IDF IDF2EB from the isosobite and BDF2EB from the one for butanedione and BDF amide 2EB from the one for butan amine and ZTF3EB from the glycerin. Actually, have a epoxy precursor. Uh, the author used three kind of different curing agents to curing the epoxy precursor, and this author used DZEBA and to either standards the precursor to compare the four kind of epoxy author synthesize here, and after that author compare to the some mechanical property of epoxy after curing, and to compare and assess the chemical thermomechanical property. The author uses some analytical methods. The first is method to check the structure of the epoxy or some compound auto synthesized by 1,8 NMR and 13 carbon NMR spectroscopy, and the thermomechanical property of precursor epoxy and resin after curing were determined by DSC, TGR, and DMA. And this is a resource and discussion. To compare the first two author list table of the with the epoxy precursor use and curing agent with the theoretical crossing density here, and we can see with the DZEBA standards is the highest, and crossing density, and the glycerol, the epoxy synthesized of glycerol and ferric acid here, and have relative high crossing density because it glycerol have a 3 OH group, and this epoxy synthesized from the 1,4-butanedione and 1,4-butanamine have a similar crossing density because it have a true group of OS or amine. And this is a table after uses some of the modern method, like the TGA and the measure stars modulus, DMA is a star modulus, and the TZ from the DSC, and we can see is all the thermomechanical depends. The precursor is a DZEP here have a highest TZ. TZ is the most important parameter to access the thermoset here, and polymer here is the highest, and this is highest TZ, and as well as the crossing here, and the status moronus, and except from the precursor, and here is a depend the thermomechanical depends the killing agent, and we can see here is IBDA have with the TZ is 85, and TL4 is with the NS storage modules, and also the crossing density is not high, and this is more clearly about the starting material, and when used and amine for curing. And we can see except from these EPAs have a highest TZ, and TZ is a glass transition temperature, and is this starting material have a structure is bicyclic, is a rigid structure, with amine have a high with TZ, and also this is amine and amine have to make the hydrogen linkage after the curing is, but is TZ not high, is the structure, and we can conclude that the structure of certain material or the molecular is very important. Is decide the thermomechanical, especially the TZ. And next author is to so clearly about the storage smallness is the important property of thermoset, and the tan delta here, and we can see except the DZEPE with the highest storage smallness, and we can see the IDB here have a good storage smallness, and it is synthesized from the structure is a bicyclic starting material in have a rigid structure in molecular, and as I said from the previous slide is a bicyclic structure is have a good a TZ in. And so we can go to conclusion. The first is a fabric from the result auto synthesized and checked by the modern analytical method. We can conclude that the ferric acid, a natural phenolic compound found in the various non-editable bioresources, process different functionalizable chemical moieties, allowing coupling and grafting a reactive function. Its aromatic structure makes it suitable for good performance thermosystem polymers. The aliphatic one for butanedione linker needs to the lowest TZ, and the three functional glycerol linker needs to intermediate TZ, and the bicyclic isosobide linker needs to the highest TZ because it have a rigid structure in molecular, and it appears from the results that the bicyclic structure of isosobide rigid differ the more thermoset structure than higher cross-link content. As we know, the bicyclic have not high the cross-link density, neither glycerol in the structure, but have a higher the TZ blood transition temperature. Even if these bio-based epoxy thermosets do not offer property equivalent to that DZEBA, but they have a useful mechanical property for ambient temperature applications such as packaging and above all, they do not present the problematic estrogenic activity observed with the DZEBA, and in addition, the internal ester or amide moiety makes these thermosets partially biodegradable and a valuable access for specific application This study therefore demonstrates the great potential of ferulic acid uh, derivative as raw material for preparation of epoxy precursor and epoxy networks. It can go further in the greening of the thermoset market, a new class of biospinance isocyanates polyhydroxyurethane, and is the meaning of the article and very useful to uh, uh, create a new thermoset to replace the DZEBA is made from the bisphenol A is a toxic compound and with harmful with the environment. And it's the end of my presentation, and thank you for watching.